Let us assume, for argument's sake, that we fail to crack those 4 passwords. Stan, Kyle, Cartman, and Kenny. Now, clearly we have succeeded in cracking them, but let's assume, for argument's sake, that we fail in our attempt, and that's fine. Okay. First thing, if we let it run, it'll try and crack any outstanding passwords that it needs to crack. And I don't think there's very many. I think it got most of them at this point, but we're going to tell John the Ripper to stop. Okay. And we're going to close these files down. We're done with them. We don't need them anymore. This doesn't run very quickly because it's a virtual environment running on a cloud service, and they never run very fast unless you spend a lot of money on them, which we can't. So we're going to create a new file, again in LeafPad. Again, how did I do that? Our applications, which is kind of like the start menu in Windows, accessories, LeafPad. And as you've noticed now, or you should have noticed by now, LeafPad is very much like Notepad in Windows. We're going to create a list of users that we want to attack. Let's assume Cartman, Kenny, Kyle, and Stan. And please note that I match their names, all right, including the case. Stan, Kyle, Cartman, Kenny, all lowercase. Okay, so I'm going to try and crack. Let's say for argument's sake, I don't actually have the password hashes. I've been able to get into the system, but I haven't been able to get in as root, so I can't hack the system. I can't get the passwords. How do I get in now? Well, one of the tricks you can try is if you're able to see the usernames or guess the usernames, you can go through and try what's called brute forcing. To do that, we're going to create a list of users, or you can just do them one at a time manually with different tabs. But we're going to create a list of users. Again, we're going to File, Save Our Work, again in our pen test folder, in our Metasploitable, and we're just going to call this users.txt. So now we've got 4 users that we can try and attack. Now if we go back and look at our service scan, one of the services that we discovered that was running was SSH. SSH is one of the options that we talked about for connecting to this. It basically creates a terminal-like access like you see here over a network, but encrypted and secured. It's a very popular protocol, but it can be used to try and log into systems once you have a list of users, and that's what we're going to do. Knowing that SSH is running, I'm going to try and take advantage of that. Okay? And again, if you're following along, go to the home, and the activity we're looking at now is brute forcing with Medusa, where we have discovered the users. We've created a file for those users. We have that file right here, users.txt. And we also have a file called rocku.txt. And it's a collection of passwords taken from a website a number of years ago, has something like 16 million passwords from a real website. So these are real world passwords that people use out in the wild. We're going to use that as a dictionary of passwords to try and crack these users across this SSH protocol I mentioned. And you'll see it is surprisingly easy to do. As I said, we're going to use the Medusa command. And we're going to type this in, and then we'll go back and take a look at what it means. Uppercase U, not lowercase u, but dash uppercase U, and we need to specify the file name, users.txt. All right. Dash uppercase P is the password, and the password is in /usr/share/word, and once you get to the R in word list, hit the tab, and then RO tab, and it auto-completes to rocku.txt. If that auto-completes for you, you're typing it in properly. If you hit the tab key and nothing happens, either you need to type a little bit more, or you've made a mistake earlier on in your command. We need to specify the protocol. In this case, it is dash uppercase M, and the protocol is, as we saw, SSH, secure shell. We need to specify a target or a host, dash lowercase h, and again our IP address 192.168.56.101. Okay? And we're going to store our results. We're going to output uppercase O, not 0, not lowercase o, but uppercase O for output. And we're going to output to success.txt. And we're going to let that run. Okay, and that's going to take a while, and we're just going to let it do its thing. But if you were following along in the notes, you can see exactly what we're talking about right here. Okay? Where is it? There it is. Don't scale. All right. So we did the Medusa command right here. As I said, the uppercase U is for a list of users. If I had a lowercase u and I wanted to attack just one of those characters from South Park, I would use a lowercase u and I would type out Cartman, for example. And then I would open another tab and type in the next one for Kenny, and then for Kyle, and then for Stan. I'd have 4 different tabs running, one for each user. But if I'm going to do a list of users, it's uppercase U. You also need to do passwords. Now you're going to have a list of passwords, but sometimes you want to go through the passwords and try each user. It's a little beyond scope for today, but that's an option as well. But I'm going to use a dictionary of passwords, so uppercase P. If I had a single password I wanted to try across an entire organization of users, I would use the lowercase p and just type in the password I wanted to test. Uppercase M is for the module or the protocol. In this case, we are talking SSH. The lowercase h is for the host or the target. If we had a list of hosts we wanted to try, we would use uppercase, but we're only talking one IP address, so it's a lowercase. And finally, uppercase O, and that is to output the results to our a result file that we called success.txt. It's an uppercase letter O, and it's not the number 0. As we watch this, you periodically see the word success, success, success. And I added these users, and I tried to ensure that the passwords were in the top 50 or 60, I think the top 50 passwords in that dictionary. So we didn't have to sit here and wait for a very long time. But as you can see, it's going through each user, and then it's trying each password until it gets a success. Now, these are all in the top 50. If the password was number 16 million in that dictionary, this would take a long time. And that's one of the things that hackers never talk about. On TV shows and in movies, it always looks almost instantaneous. In the real world, attacks can go for days or weeks. And you're just sitting there while it iterates through a series of attacks, trying to realize a compromise on a system. You automate it, but then you just sit there and hope for the best. Sometimes hackers will actually embed technology in organizations and just leave it there and collect information and probe and collect and probe and collect. But we're almost done here. And there we go. Stan's password was Superman, which was 48th in the list. Okay, so I could scroll up and see everybody's success and try and find everything, but I had it redirect all the results to the file success.txt. If I do an ls-al now, I actually see that I have a success.txt file. If I take a look at that, again with the cat command, we see that 4 times it was able to realize a password for each of those users. So even though all I had was a username, I can use a tool like Medusa and just try and try and try different passwords until I'm able to gain access to that system. Which is why every time you hear people like me telling you, use unique passwords, don't reuse them, don't use something that's ever been found, make it unique. Random passwords are the best. Use the password management tool and have a 15-character random password. Those are the best. This is why. Because if your password ever ends up in a dictionary anywhere and someone's able to figure out your username on a system, it is conceivable that they can eventually crack that system. Again, it's just a question of time and resources.